here limitations. So first we'll take the zeroth law. Actual zeroth law is defined for thermal equilibrium. Defined for thermal equilibrium. So when we see the statement of zeroth law of thermodynamics, there when A is in thermal equilibrium with B, right, and A is in thermal equilibrium with C, then B and C also in thermal equilibrium condition. That is the zeroth law statement. So in that statement, this word is there, thermal equilibrium. Thermal means temperature. Temperatures are equal. When temperatures are equal, then the law is defined. So here the zeroth law is only for thermal equilibrium. Other equilibriums are there, such as mechanical equilibrium when forces are equal, like chemical equilibrium when chemical reactions are equal. So zeroth law is not concerned with other equilibrium. It is concerned only with thermal equilibrium. That is the limitation here. So zeroth law only for thermal equilibrium, not for other equilibrium. For other equilibrium, this law is not defined. So that is the limitation of zeroth law of thermodynamics. Okay. Next we'll see the next law, that is first law. First law. Right. So in first law we have actually these are three variables which will be there in the first law. When heat is applied, right, there are particles here, gas particles here, right, and there is a piston here like this. Here I am not defining the law, so that is the other video, you can watch that video. So here we are discussing only limitations here, only the variables which are there in this first law. Here I am showing work is there, internal energy is there. So these are the three variables: heat, internal energy, and W. So actually this is the law of first law here. Delta Q equal to du plus delta W. So this is the first law of thermodynamics equation. Why writing delta, why writing D, already explained in the first law thermodynamics video. You can watch that video, right? So here we are discussing on limitation. Limitation is here. We are supplying heat here, right? Because of that there is a rise in temperature and work is done on the system so that piston moves upward. Okay, that is law of conservation of energy. Here the limitation is here. We don't know the flow of heat. The flow of heat or work in which direction. So direction is not defined here. Direction not defined. That is the limitation here. Limitation of the law is direction of this Q and W is not defined in the first law. So why to define direction? Already we know that always heat flows from higher temperature to lower temperature. This already we know. This is by nature. Higher temperature to lower temperature. So why to specify the direction here? Why? Because why this limitation came here? Because without that also automatically by default this will be the which one condition here. This heat will flow from higher temperature to lower temperature. So why this limitation comes in this which one first law is actually this condition is not there. This condition scientist not invented when first law invented by the scientist. That is heat is flowing from higher temperature to lower temperature. That condition was not there at that time. So that condition came when zeroth law is defined. So this condition came when zeroth law defined. Zeroth law came, this condition came, that is temperature flows from higher to lower. Okay. So zeroth law invented after the first law. So after the first law, zeroth law came, then this condition came. So when first law was invented, this law was not there. So why zeroth law came first? Also in that video, zeroth law of thermodynamics I defined. You can watch that video, right? But here we know that when first law invented the direction, that is the flowing of temperature from higher to lower, that condition is not there. That's why the limitation in first law of thermodynamics is this direction is not specified. direction is not specified. This is the limitation of first law of thermodynamics, right? And one more thing is here. So first limitation is here, direction is not specified, flow of heat and work. And one mission is there, that is PMM1 mission. It is called as PMM1 mission here. Perpetual motion of mission of first kind. Perpetual motion of mission of first kind. This comes under your first law. So it is an ideal machine which produces mechanical work without consuming heat. So without consuming heat, if it produces work, that machine is known as, suppose the engine is there like this. So without consuming, or which produces work, if engine is producing work without consuming energy, that is Q, without this if the machine works, if the engine works producing work without taking any energy, that is known as PMM1 machine. That is impossible in nature. So that is the which one, this condition will come in the limitation of our first law. Okay. So this kind of machine violates first law of thermodynamics. Actually, if energy supply is not there, if the engine is producing work on its own means it is violating first law. Violating first law. Okay. So this is the limitation of first law of thermodynamics, right? Again, I am summarizing. For Zeroth law, it is defined only for thermal equilibrium. For other equilibrium, such as mechanical or chemical, etc., it is not defined. And if first law of thermodynamics here, direction is not specified. Whether Q and work, the direction which it flows, it is not defined. And this PMM1 mission, if it is there, means it is violating first law. So these are the which one limitations of Zeroth and first law. Next we'll go for last one, that is second law. So second law of thermodynamics here. Here also PMM2 mission. Perpetual motion of second kind, right? If it is there, means Q, if heat is applied, then there is the amount of work, means if Q equal 10 joules, work of 10 joules, means there is no which one losses, that is friction losses are not there. So that kind of machine again violates second law of thermodynamics. So that is the second law of thermodynamics limitation. For example, if you consider steam power plant there without condenser, if the steam power plant is working, means it is violating second law of thermodynamics. So these are the limitations of Zeroth law, first law, and second law, right? So again, I am summarizing here. Zeroth law, thermal equilibrium defined. For other equilibrium, it is not defined. First law, direction is not specified. Okay, and PMM1 mission is impossible. If it is there, it violates first law. Here second law, PMM2 mission is impossible. If it is worse, means it violates second law of thermodynamics. For example, steam power plant without condenser is a PMM2 mission. It will not work. It violates second law of thermodynamics. So these are the limitations. Okay, thank you.